Hello children, welcome back to my channel. This is the chapter Quadrilaterals for standard 9. This is part 4. So we have been proving the properties of the various type of quadrilaterals, its converse properties. So continuing with that, now in this question it's given the diagonals of a quadrilateral are equal. So AC is equal to BD. AC equal to BD and bisect each other at right angles. So bisect each other at right angles means angle AOB. All these angles are 90 degrees, and it is bisect each other means OB equal to OD and AO equal to OC. So these are the data given. Now you have to prove it is a square. So to prove first, the given figure is a quadrilateral. So to prove it is a square, you have to first prove it is the quadrilateral is a parallelogram. So for that there are two methods. You can use the congruence and prove. So to prove it is a parallelogram, we have done this earlier also. You will take these two sides, these two triangles, the opposite triangles, either this or the other two pairs, and you will prove through SAS you can prove the triangle is congruent, and then you will get AB equal to CD, here AB equal to CD, and then ABO, that is angle 3 equal to angle 4 also you will get. So when the alternate interior angles are equal, then the lines are parallel, that is CD is parallel to AB and CD is equal to AB. So you can say ABCD is a parallelogram. You have to do this only if the question is of 4 marks, 4 or 5 marks. If it is a 3 mark question, you don't have to prove this. You can simply use when the diagonals bisect each other is given. So you can say since the diagonals bisect each other, it is a parallelogram. So once you prove it is a parallelogram, then we will think how to proceed for the square. Now in a parallelogram, to prove it is a square, you have to prove all the sides are equal and also the angles the vertices are 90 degrees. So again two more proofs are there. So I will draw the diagram again once more here. Otherwise I will have to keep scrolling. ABCD, ABCD and O. Already put 1, 2, 3 and 4. 1, 2, 3 and 4. Okay. Now first we have going to prove the adjacent sides are equal. So whenever you have to prove the adjacent sides are equal, you should take the adjacent triangles. Any two adjacent triangles you can take. So we will take these two triangles. So consider angle AOB and AOD. So we know DO equal to OB. It's already given. And then you have angle AOD equal to angle AOB, because it is 90 degrees given. The diagonals bisect at right angles, and then you have AO equal to AO common side. So from this you can say triangle AOB congruent to triangle AOD. SAS. From this you can write AB equal to AD. CPCT. So in a parallelogram, if the adjacent sides are equal, it's a parallelogram, it's a rhombus. It is a, now you have to prove it is a square. So, to prove square you have to prove also the vertices are 90 degrees. In rhombus the vertices are not 90, there only the sides are equal. So, here now coming to proving the angles are equal, you have to take these. This also you will remember, we have done these when we did congruence of triangles. Whenever you have to prove it, the vertices are 90, you have to take triangle like this. So, we already know AD is equal to, so consider the triangle ADB and triangle ACB. We know AD is equal to BC because we have proved ABCD is a rhombus, no? So, all the sides are equal. And then you have AB equal to AB, common side, and then you have BD equal to AC. It is given, the diagonals are equal, given. So, with this you can say triangle DAB. I will start with DAB is congruent to triangle CBA, SSS. From this we can say angle DAB equal to angle CBA, CPCT. Now, we have to prove it is 90 degrees. For that we know it is ABCD is a parallelogram. So, we know since AD is parallel to BC, therefore, angle DAB plus angle CBA equal to 180. The reason is co-interior angles are supplementary. Therefore, angle DAB is equal to angle CBA equal to 90 degrees. So, you have proved 90 degrees. Therefore, ABCD is a square. Hope it is clear. So, whatever has to be proved, you have to see which triangles that you have to take to prove the congruence. So, whenever it is the vertex is 90, you have whenever you have to prove, you have to take the triangle like this. When the adjacent sides are equal, you have to prove, you have to take the adjacent triangles, and the sides are parallel. When you have to prove, you have to take triangles on opposite sides. So, if you remember, then this, it will be easy for you to do the proceed with the problem. The next question is, show that if the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. It is almost similar to the previous question. There we had to prove it was a square. So, we did 3 steps. First, you proved it was a quadrilateral is a parallelogram. Then you proved the adjacent sides are equal, and then you proved the angles, the vertices are 90 degrees. Now, here you have to prove only rhombus. So, you will prove ABCD is a parallelogram. So, according to the question, if it is a 4-mark question, you will prove ABCD is a parallelogram using the congruence method. If it is a 3-mark question, then you can simply write the since the diagonals bisect each other, it is a parallelogram. And then you have to prove the adjacent sides are equal for the quadrilateral for the parallelogram to be a rhombus. For that, you should take the adjacent triangles. So, take these 2 triangles and prove they are congruent. From there, you will get AD equal to AB. Then you can write In a parallelogram, if the adjacent sides are equal, then it is a rhombus. So, the previous problem, only the first and second proof you have to do. The third proof you do not have to do. The next question is, show that the diagonals of a square are equal and bisect each other at right angles. So, this is a property of a square. So, what the given is ABCD is a square, that means all the four sides are equal. You have to prove AC, the diagonals are equal. So, AC equal to BD and they bisect each other at right angles. That means you have to prove AOB is 90. If this is 90, all the other angles will be also will be 90. Now, to prove the diagonals are equal, you have to take the triangle BAD and triangle ABC. That is, you have to take the triangles like this. So, that is, you have to consider the triangle where these diagonals are there, then only that CPCT you can take. So, we will start. AB in triangle ABD, AB is equal to BC, sorry, AD equal to BC, AD equal to BC, side then we also know it is a square. So, all the vertices, angle A equal to angle B equal to angle C equal to angle D equal to 90. These are the properties of a square. The sides will be equal and the vertices will be 90 degrees. So, we are going to use that also here. So, angle DAB is equal to angle ABC given, and then AB equal to AB is common. Therefore, from these you can say triangle DAB is congruent to triangle CBA, SAS congruence. So, from this you can say DB is equal to CA or BD is equal to AC CPCT. So, first thing we have proved the diagonals are equal. Now, you have to prove the angles are, the diagonals bisect at right angles. So, you have to prove this as 90. For this again you have to take the adjacent triangles only. So, we have already proved the adjacent triangles are congruent now. So, from this we will write DA now you have to take these two triangles, sorry, what we have taken was this triangle. With this only you proved the diagonals are equal. Now, to prove this angles are 90 degrees, you have to take the adjacent triangles. So, we will take the adjacent triangle DOA and triangle BOA. So, in DOA you have AD equal to AB, side is given, it is a square. Then DO is equal to OB, side this is also given, bisect each other, diagonals bisect each other given. And then you have AO equal to AO common side. Therefore, triangle AOD is equal to AOB. SSS congruence. So, from this you can say angle AOD, we will check for angle AOD. AOD is equal to angle AOB, CPCT. So, let me draw the figure again so that I do not have to keep on scrolling it. We had marked AB, CD, O. So, now AOD you got this and AOB are equal, that is you got 1 equal to angle 1 equal to angle 2 you got. So, we know angle 1 plus angle 2 is equal to 180 linear pair. Therefore, angle 1 equal to angle 2 equal to 90 degrees. So, you can say BD perpendicular to AC and BD equal to, you see the diagonals are equal and diagonals are perpendicular to each other.